All right, so we're going to talk about geospatial data management today. We're also going to learn about some more functionality we haven't dealt with yet in this course in ArcGIS Online. So if you brought your device, today will be a good day to follow along with that. There will also be an extra credit opportunity for those of you in attendance today. So we'll do that in a few minutes. So we're going to cover what is geospatial data management, right? This falls into different categories: understanding file systems, understanding which files hold which type of data, understanding data structures, etc. We're going to talk a little bit about a new field in the spatial sciences called geospatial data science. Sort of a mix of having the skills to deal with large data sets and derive insights from that, while also having a spatial component to that data. And then we'll deal also with some quality considerations for your data. What are the major sources of error in a GIS? So we've already kind of touched on a few of the themes from chapter 5. Just want to review those, kind of jog your memory. We've talked about two different types of data acquisition, right? We have primary data capture and secondary data capture. Primary being going outside or actually collecting data in some fashion. For example, on the left side here, here's the base area of Richard Bowl ski area. This is a product from a drone survey, right? Drone flew around, took photographs at different angles, and using photogrammetry, you can put together these nice three-dimensional models of the buildings. Very useful for things like insurance assessment of the property, looking for roof damage, all of these different types of things. So that would be an example of primary data. Secondary data, of course, is using anyone else's data that already exists for your particular mapping project. We've also talked about data measurement scales. So things like nominal, ordinal, interval, ratio, and cyclic data. Just need to fix this real quick. Might disappear. All right, so just to review these terms, right? If we were going out to map elevation very precisely using a drone with a LiDAR sensor on it, perhaps. We talked a little bit about LiDAR in past lectures. This is a laser range finding sort of instrument. It gives you a very detailed topographic surface. It can actually go through vegetation. That's one of its advantages. And number two, that would be using the Twitter API to download geotag tweets about geological hazards, right? First example is, actually I didn't need that animation, right? Match it up, right? One would be with B, primary data collection. Number two there would be with A, that's secondary data collection. So I know I've mentioned these terms a little bit today, but I want to spend more time on understanding attribute data types and relating those data types to their measurement scales. I want you to have a really good handle on these terms. It affects how we store data, what sort of symbolization schemes we can apply to our maps, and it also affects what sort of geoprocessing tools you're able to use. In the second half of this course, after the midterm, we get more into what's called geoprocessing, which is running actual analysis rather than just symbolizing data, choosing which data to display on a map and how to display it. We're actually going to be spending more time deriving insights from that data using geoprocessing tools. These data structures are really important for choosing the right tool. All right, so if you got your device, what I would like you to do is follow this link. I also posted it in the Teams channel. So I'll show you where that is. And we're going to open up something called a notebook in ArcGIS Online. And for some reason, this hyperlink just didn't turn into a hyperlink when I pasted it, but you can copy it out of the channel. Open up your web browser. And paste it in there. It's going to ask you to sign in. So of course, just use your normal sign in. Most people, that's going to be the single sign-on option at the bottom. I'm having trouble waking up today. You might have already realized that. This will wake me up. I think it has to do with the time change, how late the sun comes up. Challenge. So while this is loading, what it's essentially doing is loading a Python environment. So that's why it's taking a little while. I'll walk you through the components of this. But while it's loading, I'll just mention on the midterm a little bit more grading to do. But if you have any question about how those are graded once the grades post, feel free to get in touch with me by email, by the office hours, whatever. Raise your hand if you managed to get this to load on your machine. All right, a few people. Painfully slow, my God. There we go. So just to give you some context for what you're looking at, this is the homepage you see when you log into ArcGIS Online. We've spent some time already in this course in the map tab, right? That's map viewer. That's where we can make web maps, set up web maps for turning into a story map and other types of applications. I think next week in this course, we're going to be getting some practice building cool web applications based off of some maps. But the item I just shared with you is under this notebook tab. Raise your hand if you've heard of an IPython notebook. All right, great. New material here. Raise your hand if you've heard of Python before. A few people, yeah. So Python is one of the most popular programming languages. It's actually, in terms of just the amount of code written in different languages, I think it's number 3 behind JavaScript and HTML. So those first two are really used more for making websites. But in terms of working with data, programming computer applications, Python is one of the top languages. And the reason it's relevant to this course is that it is the underlying language for all GIS tools. So if you open up a tool like export data or share my map as a PDF, what your software is doing in the background is it's executing a Python script. When you're toggling dropdowns to choose different options on those tools, you're just putting in variables to that Python script. So knowing a little bit of Python, or just being able to understand some basic syntax, will really help you get ahead in terms of understanding what the software is doing. It also makes things easier in terms of customizing your tools. If you want to do an analysis that doesn't exist in the software yet, you can build that yourself. It's also extremely useful for automation. So if you have a repetitive task, like let's say every day, there's new data uploaded with regards to case counts for a certain disease in public health. Or maybe there's new data in terms of like where populations of elk are at a given time. And instead of doing all the steps manually every single day to update your data set, you can do a little bit of simple programming to have ArcGIS do that for you automatically. So notebooks over here, this is a good place to explore this theme of data types. And if you go to the notebook tabs in ArcGIS Online, it'll show you all the notebooks that you have shared in, that you have saved in your account. And you'll also see the ones that are shared with you through the organization. So raise your hand if you're able to get this open. All right. In the back, I see you shaking your head. What's going on over there? It's still loading, or? Okay. Tell you what there is, I have a Google version of this, which is a little bit quicker. So let me paste that link in the Teams as well. While I'm doing that, what you can do is just kind of start reading through this document, get a sense for what you're looking at, and I'll walk you through it in a second here. Okay, so for whatever reason you're having trouble getting the ArcGIS Online environment to work, go back to the lecture content channel on Teams. I did just post a link to a different way to work with these data. It's a very similar concept, except for you need to have a Google account to open it. You can check that out if you're having trouble with the ArcGIS Online option. I think if you're patient, this will eventually spin up. So what is a notebook? This is a way of looking at some basic code and providing some tools to annotate it, explain what's going on, add some context to it. And we can execute the code in basically little chunks. Instead of running the entire script in your entire document, you can do it in short code blocks. So if you click on some of these lines, you see that they're selected, right? And in this drop-down menu here, you can see what type of information is being conveyed in that block. The two that you're going to be using are code and markdown. So let's remake this heading here, just to get a sense for what this is, right? I'm gonna delete this. If I want to add in a heading that explains what this notebook is all about, I can insert a cell using that plus button in the top left. I can move it up and down using these arrows. And it's going to default to code, but for just a heading explaining what's going on, we want to change that to markdown. Markdown is essentially just the text and graphics that are explaining what the code is doing. Let's start by putting 2 of the pound symbol or hashtag. And then we can recreate that text, right? Data types in GIS, Essentials of GIS, Chapter 5. And if you've got it set to markdown, and if you put those 2 pound keys before it, that essentially gives you a heading 2 size. If you've ever worked with HTML, you have heading 1 is the largest heading, heading 2 is the second largest, etc. If you wanted to make it a little smaller, you can keep adding those symbols to change the formatting of your headings. Making sense so far? All right, so as you can see, the next cell is another markdown cell. And instead of a heading 2, I've made it a heading 4. So it just it appears in a smaller font size. It's still bold, still a heading, but a little bit smaller than that top. You've got some tools here for cutting and copying your cells, etc. And this first line of code is doing a couple of things. So it's importing what's called a module. A module is a grouping of functions, right? It's instructions to do things in Python. And by importing the module, it brings in all the functions in their pre-existing versions and allows you to use those. So for example, we have a function here, GIS, and that function, what it does is it signs into ArcGIS Online and uses your credentials in ArcGIS Online to do things. Right? It's just like signing in on the login screen. So we're importing a module here, and we're using that function that came along with that module to sign into your home ArcGIS Online environment. To execute that code, we just want to highlight the cell and hit this button called Run. While code is running, you'll see a little asterisk in brackets on the left side. That means it's processing. And when it's done, it'll give you a number, right? It said, okay, this executed. I didn't see any errors here, no syntax issues. It worked. We get the number 1 in those brackets. If, for example, I took that home out of the parentheses and I had my syntax wrong, and run that again, it's going to give me an error. So this is extremely common if you're working in Python. You're going to get errors. You're going to make mistakes. But the mistakes, the feedback it gives you is actually very helpful for troubleshooting. So in this case, it says home is not defined. That means it's looking for something that is not there. But this function is looking for some text, so we need to put it in quotes. All right, so think back to your lab last week, right? You had to calculate a field. You actually had to calculate 2 fields. And part of that instructions was to bring up the fields view in ArcGIS Pro and set a data type for the new fields. Does anyone remember which data type we used for population density? Was it a string? Was it a float? Doing some nodding. Don't be scared to raise your hand and take a guess at it. Yeah, it was some numeric value. It was probably a float value if you followed the instructions exactly. Integer would have also worked. So in programming in GIS, right, data types are essential. They define the type of information a variable can hold. They also control what type of symbolization schemes we can actually apply with those attribute values. So let's walk through some different data types and give you some examples. String is a fancy way of saying text. Technically speaking, it's a sequence of characters. And in a programming language, like Python, string values are always included in quotation marks. What's going on in this code here is that we are assigning a string value to a variable. Something going on with my keyboard here. Anyways, bear with me here if I have any issues. So what's going on with singing name here is we're assigning a variable and we're storing a text value to that variable. So in this case, city name is equal to a string value, San Francisco, right? And this would be a good example of the type of information we can store in a string field. Text, right? Qualitative values in general. When we run this code, what we're doing is we're actually printing out that value after some string text. So we're adding in here, we're going to print city name followed by the variable city name. So what I could do, hold on a second, I need to fix this. Now I've gotten into full screen mode and my keyboard is locked. Like my function key is being held down. Anyways, yeah, so what we can do here is actually change. Oh, my shift key is stuck now. There we go. Got it. So let's go ahead and change this variable to Denver or some other city of your choice. So if we change that string field there and assign it to the variable again, it's going to redefine that city name variable. Instead of printing out city name is equal to San Francisco, it's going to print out city name is equal to Denver. The other thing we're doing is we're using a function which is just built into the base Python distribution. It's not associated with any package you have to bring in. And that function just gets the data type of your variable. So, right, to simplify this, we could just have this function print, which means it's going to actually print out the values, the type for the city name variable, right? We could experiment with how this changes if we just type in the number 1. This is not going to give us a string variable anymore, right? So if we change city name to 1, notice that Python automatically recognizes the data type. Similar things happen in ArcGIS and ArcGIS Online. And so now our city name is assigned to an integer value of 1. It's going to print out 1 and tell us that that's an integer value. We can also change this back to a city, right, by putting it in quotes. Python knows that this is now a string value again. We can change this text here back to city name. And we can add in more context to the second line, right? Data type, in quotations, and a comma to separate the two different things that are being printed here. And we'll be back to our string value. Our class is str, which stands for string. And we're printing out that variable string value there, San Francisco. Anyone still having trouble getting it open? Or are we good to go? Good? Cool. Any questions on what I just did or any terms that you want me to review? Right, so you are programming. It's fun, right? We've got a couple more markdown cells here. We can click run on those. It's not going to do anything. I want to also show you how to do bold and other sort of formatting in Markdown. Sorry, my screen wasn't shared there for a minute. Yes. Thanks, Wesley, for letting me know. All right, we're back. So if you want to add bold text to your Markdown, One way to do that is to use the heading symbols with the hashtags or the pound keys, but another way is to add asterisks around your text. So if we just type in numbers to or letters to a markdown cell, it's not going to have any sort of formatting. But let's say we want to make that description bold. You can put 2 asterisks on either side of the text you want to bold, and that will achieve the desired result. All right, so our next data type, probably heard this term before, it's a float. Float is short for a floating point number, which is a fancy way of saying it has a decimal place. So if you need to store data in a field that has a decimal place and it's numeric, this is the data type for you. So for example, we can assign the value 37.7749 to latitude, and then we can print out that value and the data type for that value. And Python recognizes here that it's a float value. If we didn't add that decimal point, right, it would actually default to integer. Before you keep going, go ahead and save this to your ArcGIS Online workspace using that Save button at the top right. All right, and the next data type is integer. We just kind of went over what that is. It's a numerical value. It doesn't have quotations around it. It doesn't have a decimal point. So it's a whole number, right? And it's really good for storing variables like population, where having a decimal point doesn't really make any sense. There's never a situation in which we have a half person living somewhere. So again, population is a good example of an integer value. Raise your hand if you've heard of a Boolean data type before. A couple people, 1 or 2. So Boolean is just a true or a false. It's a really good way of like checking your data for certain conditions. You could actually run a calculation where it goes through all of the counties in the United States and returns a true or false value if, let's say, you're above a certain population threshold. If the area has more than 10,000 people, return true. If it doesn't, return false. So you often see a Boolean data type when you're dealing with some sort of conditional test. So we started another variable here, is coastal. We've set it equal to true. In Python, depending on which editor you're using, but definitely in ArcGIS Online notebooks, if you type a Boolean value, it turns green to indicate that it's recognized as a Boolean value. So we can also type in false. It also recognizes that. So for San Francisco, right, it is a coastal city, so that's true. And the data type is going to be Boolean. The final data type you will often come across in ArcGIS and can cause you some real headaches, especially if you are dealing with answering questions about temporal change, is dates. So you have to treat dates in a very special way because they have a specific format, right? They have a month, day, and year. They also have times associated with them. In practice, the most common time you will be dealing with dates is when bringing in a spreadsheet. And spreadsheet programs have a sort of unique way of dealing with date values. In Python, this is how it works. You actually need to import a package that deals with formatted date values. So we're importing the date function from the package called datetime here. And then we're using the date function to convert these three numbers into our actual date value. So we can set a date of the year 1850, the month is 4, and the day is 15. So that represents April 15th, 1850. Change that, right? We could do 2023. It's going to tell us our date is April 15th, 2023. And we could modify that variable as we need to for our particular data set. Over here, this is some annotation. And I want to tell you how this works really briefly. So if I didn't have this pound symbol there, it's going to recognize this as code, and it's going to try to execute that code. When I hit play on that cell with this line here, it's going to say there's a syntax error here. Basically, I don't know what you're telling me to do, so I'm raising an error telling me to fix it. But if you just want to have some text there next to your code to kind of remind yourself what is going on, or if you're sharing this with other people, you can add that pound symbol, and it'll mark this as just text annotation. It'll tell the Python environment to just ignore that text, anything following that pound symbol on the same line. So give that a try yourself. You could go to the next line, type in that pound symbol, and say this line of code prints the date. I specified the above variable called established date. So really good practice if you're working on a project that involves any sort of code is to use this to remind yourself what's going on, explain what you're doing. Just makes your code much more readable and able to be understood by a broader range of people. So I've got some text in here with how spreadsheet programs deal with dates. It's kind of interesting. Microsoft Excel being the dominant spreadsheet program, what they did is they just said January 1st, 1900 is the day 0. So if you specify that date in a cell in Microsoft Excel, it's going to be equivalent or stored as the number 1. The next day, January 2nd, would be number 2, etc. What this allows you to do is subtract dates from each other, right? If you're actually keying those numbers to calendar dates, you can say how many days apart are these two dates, etc. How much time has elapsed? But it's really important to know how this works because it affects how data translates into other programs, including ArcGIS. So to read more about this, check out these notes here. I won't spend much more time on it today, but just be aware that dates are stored as a serial number, usually keyed to a reference date. If you were doing a historical study that predates January 1st, 1900, you would have to set up your Excel differently than the default configuration. So let's do a recall question. This next code block, I set up a interactive question for you. It doesn't really matter what's going on in the code right now. Just highlight that cell and click run. And it's going to give you a question box here that you can go ahead and fill in. So the question is, for each of these data types we've just gone over, right, string, integer, float, Boolean, and date, what is the attribute measurement scale that makes the most sense to store in those data types? Remember, nominal data would be something like the address or the name of the feature on the map, like Montana State University, Reed Hall, Montana Hall, etc. Ordinal will be a ranking, like this person finished first in the race or third in the race, or this is the third largest city. Interval and ratio data are both quantitative data sets. The difference being that ratio has a true 0, interval does not have a true 0, and cyclic is something that repeats within a certain range. So take about a minute and give that a shot. And when you've filled out all the fields, you can hit this button here to check your answer. If you're good at understanding Python syntax, the answer is right there. But it's more fun to actually try to recall this information. Some of these are not concrete, right? We're looking for sort of the most common answers. Like, for example, integer values might be used to store ordinal data, that ranking, right? 1, 2, 3, 4, etc. That's a really good use for an integer value, but integers can also be used to store ratio and interval data as well. Yay, go me. Did you get it on the first try? All right. Well, keep trying if you did not. There's actually two possible ways to answer this question. You could also do this combination. All right, so nominal data makes sense you would store it in a text field. Interval and ratio data or ordinal data can all be stored in an integer field. Something like the pH of the soil or the height of a tree or the distance from the nearest gas station, that could be stored in a float field with a decimal place, right? Numeric value with a decimal place. In ArcGIS, Boolean values are stored in nominal values would be associated with a Boolean field, right? So true or false is essentially a nominal value assigned to a special meaning, right? Testing a logical condition. And then a date would be cyclic. It's bounded in a range. It goes from 0 to 365 days of the year. Or if we're thinking about time, we're going from 0 to 24 hours in a day. Any questions on that? Awesome. So let's run the next cell. And what it's doing is it's setting up a table, just like you would see in a spreadsheet program. In Python, this is called a data frame, but that's not super relevant to this exercise. We've just got our field names and attribute values associated with each field. We've got latitude and longitude values, populations, and a Boolean field as well. So this is like something you might see when working with geographic data. We've got of course, city name is going to be a string field storing text values that are nominal. Lat and long are both float. Population is integer. And is coastal is Boolean, just like we went through in the steps above. And this last line of code I've provided you with just uses a library called pandas, probably the most commonly used library in Python. And it's just taking this table and exporting it as a comma-separated value. So you can hit that. If you're on Google Colab, it's going to go somewhere. I'm not exactly sure. But in ArcGIS Online, to find that file you just created, you go along that top ribbon there. Go to Files. And then if it works correctly, you should have a CSV file right there. You can click on, and it will download from your web browser. And you've got a table, right? You've got lat long values, We've got attribute values, we've got city names. So let's say we wanted to work with this data and figure out what sort of operations are possible with these different data types. We can go back to GIS Online. Or you can do this in desktop too. Yeah, question. Yeah, so just this last cell here, this is taking the variable that stores that table, and it's telling it to convert to a CSV right there. We're giving the CSV a name, and we're telling it to drop this index column right there, 0 through 6. So if you just run this, and then along that top bar in ArcGIS Online, if you hit Files, it'll bring up any files that are generated by your script. Did you find it there? Cool. And you just click on that link and it'll download to your downloads folder. So in ArcGIS Online, now we can click that item in the content area for new item. You can select your device. If you're on an iPad or something, you might have trouble doing this. So maybe just take notes. You can do it later on a computer. You might be able to figure it out depending on how savvy you are. So I'm just going to go find that CSV file I just generated. I'm going to select that top option to add the CSV and create a hosted feature layer or table. And this should look familiar, right? We've set up all of our data types for our table, and they're automatically being recognized by ArcGIS Online. So the name is a string, lat long or double, which is the same thing as a float value. It just means that it has more possible decimal places, so higher precision. Population is integer, and is coastal is a string value, right? That's our Boolean field. We can leave all of those automatically recognized fields the same. It's going to ask us how we actually locate our data, and it automatically recognizes that we have a latitude and longitude field. We leave that the same. And then you can give this a name and hit that save button. And this will publish the feature service to ArcGIS Online. Once that completes, you can open your data set in Map Viewer. Cool, right? There's your data. It just came from a table in just a few seconds, probably like took a whole minute. We created a hosted feature layer in ArcGIS Online. Now we can make maps using these data. I'm going to change the base map real quick so I can see those points a little bit easier, a little bit more easily. And earlier I mentioned that the type of symbolization really does depend on the field type, right? We go over to the right side and we go under styles. The default is to just map every feature using the same symbol. But if we select a field by clicking on that field option right here, right, we could add city name, and it's going to give us style options for that city, for that particular data type. So this is a unique symbolization scheme. It's qualitative, right? And that matches up well with the string data type. I don't think this is the most effective way to do it because we don't really need to have a different color for each city, because what we could do is just have a text label giving us the city name. I'm going to change the field I'm using to one of those float values. Sorry, the float values are the latitude and longitude, so those aren't possible right now. Let's choose population instead, which is integer. And because we have an integer data type, now we have a lot more options for symbolization. In lab this week, you'll be making dot maps. This is one type of a dot map, right? It's graduated symbols, where the size of the symbol corresponds to the population value. So different data types unlock different symbolization possibilities. Let's explore that Boolean field as well. These are really useful for having a true false. It's really useful if you want to show differences between cities. So let's select the is coastal field in our symbolization tab. Note that we've only got two values, true and false. What we could do is change these colors to something a bit more intuitive. Maybe true is a nice coastal blue color. False, let's make it like a earthy yellowish color. Yellow brown, something like that. We can also modify the size. One thing I haven't told you about in ArcGIS Online yet is that it has this option, it also exists in ArcGIS Pro, to adjust the size automatically. Sometimes it's nice because if points are really close together, it'll change them to be smaller at different scales. I'm just going to turn that off to simplify this exercise. Make it a nice round 15 pixels. And the final thing I will do is I want to label this layer. So if you find the button for labels, you want to tell it which field to use for labels. So in this case, we're going to select city name. We can tell it at which scale ranges we want to view these labels. And once we're happy with it, you could also do things like change the font, etc. I'm just going to leave it as it is. We can exit out of there. So for your extra credit, I know I've just got 1 minute left here. What I want you to do is save this web map to your workspace. Share it, at least at the organization level. You do that over here. We save as our cities map. And then this button right here, sharing the map. You will need to at least share it with the organization. You can also do public if you prefer. When I hit that button, it's going to recognize to share this map, I also have to share the layer, right? The layer has to be shared as well. We want to use this option for update sharing. Then just take that link from your map, head on over to the Teams channel, and I'm going to start a new thread here. Post your map links. And you can reply to that thread. I'm going to add my link right there. Please don't just save my map to your workspace. That would be kind of lame. But yeah, if you do this, I will go through your midterms. And if you missed a question from the true false multiple choice, I will give you those 3 points back if you complete this little exercise. So the perks of getting up early. Yeah, question. I will lock it by the end of the day. So make sure you get it in today sometime, and you'll get your extra credit. All right, thanks everyone. I'll see you next time.